So our first speaker is Pat Beauchamp from JPL, and her presentation is entitled Increasing Small Satellites Reliability for Planetary Science Missions. And then welcome.
Yeah, I guess I have to use the microphone. Yeah. So if someone asks a question, I'll try and repeat the question. Thank you very much, Brooke. So I'm going to tell you about an initiative that right now is a public-private initiative that we've started in the United States, and I'll give you a little bit of background before that. There's many people involved. The prime people that have been pushing this are myself, Harold and Doug from JPL, Linda Furman from MIT Lincoln Labs, Erica Sullivan, Tom Fairbanks from Los Alamos, Mikkel, Jesse Leitner, and I just realized that the other prime mover besides myself, Mike Johnson from Goddard, isn't on this list. So Mike and I started this about a year ago because we were very interested in CubeSats, small sats, and we had a notion of where they should head and what we could do to help. So next slide. Is this the... Okay. Okay. Okay, got it. As many of you know, there is quite a transformation going on in the industry in that CubeSats, small sats are being built now, not just in universities, which have done an excellent job of showing that we can do CubeSats, but also in industry and now the government agencies. Of course, once the government agencies get involved, we're all very concerned about one extra thing that most universities are not worried about, although some of the PIs have expressed a lot of concern. If you're going to launch something, they actually want it to last. And the agencies, of course, do that, want that very much indeed. So we've been looking at what science can be done, and this... let me see if I can get the point. Yeah. So this was a symposium held in 2015. This was held in Irvine, California. It was in the auspices of a committee that was an NRC panel. It was the Committee on Achieving Science Goals for CubeSats. And it was an amazing event, if you will. There were tens of posters and participants, close to 100 actually, that came up with science ideas. And it was very amazing actually to those of us that knew there was science that could be done with CubeSats, but not believing that there was sufficient breadth of science and depth of science. So this was really good. And what was even more interesting, that it was chaired by Thomas Zurbuchen, who is now our Science Mission Directorate Associate Administrator at headquarters. So not only was he a skeptic turned proponent, but he actually is now at NASA headquarters. So this is just the introduction to the topic, and then I'll talk a little bit about some of the planetary missions or studies that have been done. So as I said, small sats can enable a breadth of novel missions. The ability to quantify and improve the confidence is something that we're worried about and want to see happen. And what we figured the best way to do that was actually involve the community, the industry, the people that are actually building the components, subsystems, and in some cases the entire spacecraft. But before I get into that part of it, I'll just point out that we actually have been building planetary. This is the Planetary Science Conference, and we actually have been building planetary CubeSats. JPL started building these this was about 2013. So that was about 4 years ago. This actually didn't launch. We lost the launch opportunity, and it'll likely go on a future launch opportunity. But the point of this Inspire was to actually try and build this in-house along with partners, and to see what the issues were in building the CubeSat. It's a 2-3U CubeSats, which was an experiment to show we could do interplanetary UHF communications planetary deep space communication, and some magnetometry. But as I said, it hasn't launched yet. It will, I hope, launch soon. One that is going to launch soon, it's going to launch with InSight in May of 2018, is Marco. Marco is going to be the relay for the communication for InSight. There's a problem that arose, is that we couldn't see, we couldn't communicate during the descent, and so this is the methodology that we'll be doing that. There's 2 CubeSats, 6U CubeSats that we've built. The radios are, The radios are IRIS DSN compatible, software-defined radios, and it's got about a 0.6 reflector array antenna that'll only be 8 kilobits per second from Mars, with a 70-meter dish, but we will be able to do that. So this is actually going to fly with InSight. The hardware is all ready to go. One is completely built up, Marco A, and Marco B has in the process of being put together again now. There was a hold, of course, on InSight for a couple of years. So this mission stood down for a couple of years. Marco A was ready a couple of years ago. Okay, so one of the things that NASA headquarters did, which was really amazing in terms of the response, was we did, on Planetary Science Division, put out a call for small-sat studies and got 102 responses. And that amazed everybody, I think, including NASA headquarters. So that came out in 2016. There was 102 proposals, and the 19 chosen fell into the categories of Venus, the Moon, small body, Mars, and icy bodies. So you can see there were 4 into the Venus category, 5 into the Moon, 3 small bodies, and Mars and outer planets. So the push to do planetary science with CubeSats or small sats, most of us believe, I think, that that the form factor of CubeSats is not going to work for many interplanetary missions or planetary missions because of the propulsion, because of other things that have to go on. But the notion of using CubeSat technology for small sats is really viable. So Goddard has also had the same problems that we had in just making sure that the vendors actually understood how to do reliable components and subsystems. And they've been developing Dellinger, which is a 6U out-of-the-box subsystems, and they've had the similar issues. This is an Earth mission. It's gone to the ISS, I believe, and what we've decided to do, working with Goddard and working with other agencies, as I said, is have this private-public collaboration, this initiative that will work with vendors to figure out how to do reliability within the cost realm of CubeSats and small sats. The whole idea is not to try and impose our normal reliability, quality assurance, procedures on the vendors. So as I said, this is an initiative launched last year. The charter is to define implementable and broadly acceptable approaches to achieve reliability and acceptable risk postures associated with small sat missions, and making sure that there's do no harm to the primary mission. We want to make sure that we maintain the cost efficiencies associated with CubeSats and small satellites, and we are considering the supply chain elements, constraints as appropriate, and trying to figure out how to do this both at the architectural level, the mission and system level, as well as the component and subsystem level. So it's really, it sounds fairly straightforward, but in fact, we're finding it very difficult. So far, we've only involved the US agencies and the US vendors, but I wanted to make sure that we get this message out to the European and other communities as well, just to make sure that we can spread the word, if you will, and see if we can achieve this in a global way. So we've had one technical exchange in a exchange meeting. The goal was to get industry inputs. We had actually gone in with some ideas of what we would do. There were many, many attendees that we've actually limited these meetings to about 50 people, and mainly US. But the purpose here was to try and get inputs, because we went in thinking, oh, well, we should maybe try this, this, and this, thinking we were being fairly progressive. And industry went, no, I don't think so, this won't work. And so we in real time, came up with some new schemes on how to do this. And we're still working on those, but there's really three approaches that we're looking at right now. One, which is a confidence-based approach, and that may or may not change because this is a work in progress. This is not, we have no final solution to how we do this. We're looking also at model-based approaches, ranging from MBSE to other approaches, and then knowledge sharing. And that needed a lot. A lot of people really wanted to have that, and I'll talk a little bit more about that in a moment. The one thing that needs more attention, and we didn't give it that much attention in the beginning, is software. And that needs a lot more attention, how to get the reliability in the software area. So we'll be working on that in the next few months. So we're looking at this confidence-based approach. And again, this is work in progress, so we're always open to new ideas. If people have any thoughts on this or ways of doing this would be wonderful. So instead of characterizing risk, a CubeSat mission should perform some level of assurance activities to achieve a threshold of confidence acceptable for their mission. And you may say, well, what does that mean? And it can mean something like this, and this is just an example where you have everything on the risk tolerance area from very low, moderate, high to very high, and mission characteristics, mission criticality, Earth mission, deep space, single satellite, constellations, flight development. Again, this is just an example. So, for example, the agencies that are involved with national security have a very low risk tolerance. Let's see, there's a high a high risk tolerance for technology demonstrations and teaching systems. So universities, for example, are not as concerned necessarily with long life, high reliability systems. So this is a way to actually be able to pick and choose between these areas on how you would actually go about thinking and communicating reliability. So if somebody would say to you, how is this, how confident are you this will work? That would be one way to do it. Similarly, the component level has a similar type of mechanism. The reviews would be quite formal for low risk tolerance, going to higher risk tolerance where there'd just be internal reviews, and again, much less oversight for the low risk, high risk tolerance areas. What we want to do, and we're just walking this path right now, is looking at model-based system engineering, trying to figure out how we can use that to do reliability. And again, I won't say much about that because we're just about working on that right now. And knowledge sharing. One of the things that we have at NASA Ames is we have a website which we're going to post and have posted all the information on this technical interchange meeting we had. And we'll be actually putting things on that website, a lot of information on that website. And right now we're just determining the architecture of that website and figuring out what we're going to put on there. But it'll have maybe, the parts information and how we do things. Ongoing activities, we're working on these. Okay. We're working on investigating the use of sophisticated systems. As I said, we're looking at safety cases, formal assurance cases, and model-based assurance. Working on menu-style framework, and then we're coordinating with a group that's been working on mission assurance improvements workshops. We're holding another TIM next month, October, yes, next month. And again, we'll be looking more into the model-based approaches, best practices for small sat system and design development guidelines, and knowledge sharing. We're asking people what they want to see on a website, as well as giving information we think would be useful. So the take-homes are small sats, we think, enable a breadth of novel missions. The ability to quantify and improve the confidence of small sat-based missions makes the potential of these real. And we've decided that thought and action derived from thinking about this in a coherent way would be helpful. So there's a lot of people involved in this. This is the results of a lot of people's work. And a special thanks to Elizabeth Klein-Lebing from the aerospace for her contribution. Mike and I have continued to honcho this, but as many of you know, Mike and I, this is not our field for either of us. So if you have any questions, you can ask any one of us. But I think I'm done with my time.
I'm told that the Minister of Finance of Latvia will be giving a short talk at the end of this session. So I'm going to be keeping the time very, I'm going to make sure that you guys end up on time. Let's entertain one question to Pat Beauchamp's presentation, if there is one. Yes, over there.
One comment. Europlanet is aiming to try and get the European community to do a very similar exercise, because we feel we're a little bit behind the curve on the same type of technologies. There is an opportunity in the forthcoming Horizon 2020 to write a bid to do this. So if people are interested, please contact us, because we're at the stage of trying to get interested parties to join us. And of course, we'll talk to you.
Yeah. The comment was just for the cameras is that Europlanet is thinking about doing a similar thing, and we can talk later, because I think that would be wonderful. And that was part of the purpose of coming here, was to make sure that we open this up to a larger community.